first thing you're going to want to do is bring in your files. There's 3 files. POPs disease, which includes populations and disease counts. A grid, which is we're going to use for smoothing. And then the study area, which is Iowa counties. So the first thing you're going to want to do is just orient yourself, and what we're going to do is put the grid on top, and we're going to change the color of the symbols so that we can see them. So you can open Symbology, and you'll get this window open, and you can click on their symbol and you can change the color. So I've just made all the grid cells red. Go ahead and make them a little bit smaller too, but I'm going to. Then I'm going to hit apply. So for the first step, we're going to create buffers of 8 kilometers around each grid. And what we're going to then do is, after that step, we're going to capture all of the populations and disease cases, and we're going to assign them to each buffer. So we can go to Analysis, and then Tools, and we can type in Buffer. We're just going to do a standard buffer. Our input feature is going to be the grid. The output feature is, we'll just call it grid buffer. And as far as the units go, we're just going to do 8 kilometers, which is about 5 miles. Not exact, but close. Leave all the defaults. And then we're just going to go ahead and press run. So now we have a buffer around each of the grid cells. So the next thing we're going to do is a spatial join. But we're going to be using the spatial join from the geoprocessing tools. So you can do a search on spatial join, and there's spatial join. So far what you're going to want to do is use the grid buffer. So we're going to be joining the population disease file to the buffers. So grid buffer, and then the join features is our pop disease. We're going to call it grid buffer spatial join. And then the one thing that's important is to change this to one to many, because there's overlapping, right? So we can't assign one set of cases to each buffer because some cases and populations fall in multiple buffers. And then we're going to leave all of the defaults alone. We're going to press run. So it will take about a minute to complete, and it really depends on the machine that you're using. It could take a few minutes. It's calculating a lot of numbers. So we can go ahead and open the file and just take a look at it. So there's 2 things that I want to just quickly explain. One, right, is that there are 1,025 grid points. And if we open this file, right, it's going to have a lot more. Because again, there's overlapping populations and cases in that pop disease file. So now we have 505,789. So the next thing we need to do is we need to summarize the populations and the disease counts for each grid ID. So this grid ID has all of those same IDs that, for the grid file, they've been converted over to here. So you're going to end up with, obviously there's 1,025 different grid IDs, but of course we have multiple ones because there are overlapping cases and populations that fall into each of the buffers. So I'm going to show you really quick. Let's look at the pop disease file. We haven't looked at it yet. And we're going to see the fields that we want to summarize. There's 2 of them. So yours might look slightly different. I added these earlier today. But there's going to be a disease observed. So this is what we want. These are actually the counts of disease per point, basically. So we want to sum that, and we also want to sum the populations, right? So cases divided by population becomes a rate. So we go back to the grid buffer spatial join file. We're going to click on grid, and we're going to do a summarize. And what we're going to do is select those 2 fields and sum them. So the disease observed, and we want to sum. And then we want the population, and we want to sum that. And then everything else will remain the same. So it's going to produce this grid buffer spatii statistics file. So important to open that and take a look at it. We should be back to 1025, so it should have summed each cell, so each buffer that we had. See, we're back at 1025. And what we have here is, again, it's summarized for each buffer the number of disease cases, and then it also summarized the population. So the next thing we need to do is actually calculate the rate. And we'll calculate the rate and we'll multiply it by 1,000. So to do that, we need to add a new field. So we'll call this rate X. This rate X, we want to use a double, and then we're going to set 2 decimal places. Probably could get away with 1, but we'll just do 2. And then what you do is you can save that. And then once we're done with that, we're going to do a field calculation where we're going to actually calculate the rate. So there's your new field that you created. You're going to click on it, and then you're going to do a calculate field. So our math is going to be the sum of the observed diseases divided by the total population times 1,000. You could put brackets around it for order of operations, but I did this earlier and it's okay. I think it works out fine if we don't. So sum of the observed, sum of the pop, times 1,000. And there's our rates. So now that we have that file, you're probably saying, well, how do I map a file, right? How do I map a table? You can't map a table, so we need to join it back to the grid. So this grid ID is found on our original file. So what we can do is we can do a join. This is a tabular join, add join. We're going to be, the join field is going to be that grid ID, and we're going to want to do that spatial statistics file that we just based on grid ID. So you can hit OK. And then what you can do is, of course, open this file up, and then you're going to see that your rate is connected to it. So then our last step is going to be to smooth rate. So we're going to use that inverse distance weighting method that we discussed and I demonstrated in class. We did a little in-class assignment on it. But what we're going to do is go back to our geoprocessing tools. You can type in inverse distance weighting, IDW, and we're going to want to use the one from the Spatial Analyst toolbar. So our input feature is going to be grid. Our Z value is going to be that rate X that you calculated. And we're going to leave everything the same. Right? So it's going to take 12 points, meaning that it's going to take 12 grid cells and use those 12 grid cells to calculate the smooth rate. So I'm going to leave everything the same and I'm going to hit run. Okay, once it's done, I recommend that you turn off the files that you were using. You can leave the county file up. And what we can do with the county file is go to symbology and then just click on symbology. And you can just go to the gallery, and what we want to do is just make it hollow. So we want to see the counties on top of the smooth rate. So that is it. So for the final part, you just basically need to do a screenshot. Make sure you get the legend as well. But this is basically the smooth rate based on the population and disease files that we had. So these were locations of where population and disease were located. We laid a grid over top of the file, right? And then we use those grid points to capture the cases and the populations based on our 8-kilometer buffer. And then in the last step, we use inverse distance weighting to smooth the rates. So that is an example of a non-adaptive smoothing method.